Use algebra to solve cos x equals 1 minus 3 cos squared x over that domain, then the general solution. It's a quadratic equation, so we solve quadratic equations by moving everything over to one side and making it equal to 0. Now, if we can factor, factoring is the nice way to solve this. So if I start and I say, and by the way, you can't factor this one, but if you tried to factor this one, this is how you would set it up. Set up my brackets, and if I could factor it, this is the easiest one in the world to factor, because to get 3 cos squared, the only option is 3 cos and cos. To get 1 as my last term, the only option would be 1 and 1. And the last thing I'd have to decide is the signs. It has to equal -1, so 1 needs to be positive and 1 needs to be negative. But the problem is that our outside is 3 cos x, our inside is 1 cos x. Whether I'm adding or subtracting, 3 minus 1 or 3 plus 1 never equals 1. No matter what I try, this would not work. So it's easy, it would have been easy to factor because there's relatively no guessing and checking or steps that you need to do to figure out what the numbers are going to be, but none of the numbers work. So we have to go to our quadratic formula. Take out our formula sheet. It's set up for x squared, and it says x equals. We have cos squared, so we will write cos x equals negative b plus or minus b squared minus 4 times a times c over 2a. And simplifying this, gives us cos x equals -1 plus or minus the square root of 13 over 6. And what this means is we have two possible solutions. One is cos x is -1 plus the square root of 13 over 6. And one is cos x is -1 minus the square root of 13 over 6. Okay, I'm going to take out my calculator, and I am going to find the reference angle for both of these, and I am going to make a tiny mistake, hopefully just one, but a common mistake, and I want you to see if you can find my mistake. So here we go. Did I write anything? Did I make a mistake already? No, I'm good? Okay. I tried to do this with the other class, and I made 17 mistakes before I made the common mistake, so it was really bad. It's like I wrote numbers down wrong, and I wasn't trying to make other mistakes. So I'm trying to only make one mistake. If you catch me on another one, perfect. So how do I find a reference angle? I go to my calculator, because obviously this is not on my unit circle. And second, first of all, make sure that I'm in radians. I am. Cos inverse, I'll use my fraction button so I can write it exactly as it shows up. And the first one was -1 plus the square root of 13, all divided by 6, bracket, 1.12, so that will be my reference angle. 1.12. And on this side, do the same thing. Cos inverse of, use my fraction button, -1 minus the square root of 13, all over 6, bracket, enter, 2.45. And I've made a slight mistake. What do you think it was? Well, there'd be a reference. There's two possible solutions. So there will be a reference angle for this side, and there will be a reference angle for this side. Okay, yes. So when you're finding your reference angle, we do cos inverse of a positive value. The hard part here is recognizing which one of these are positive, which one of these are negative. Can you see that the first one I did correctly? That -1 plus the square root of 13 is going to be a positive number. To do a little bit of estimation here, but square root of 13 is 3 point something. And -1 plus 3 is going to be a positive number. So this one's positive. In fact, I know that on this side, I'm going to be looking for answers in quadrant 1 and quadrant 4. But on this side, I have -1 minus square root of 13. That top of that fraction is going to be negative. And so cos x is negative, telling me this side's going to be in quadrant 2 and quadrant 3. But when we find our reference angle, we have to do cos inverse of the positive value. And that is hard to see that mistake. Also, a reference angle is always in quadrant 1. It's always between 0 and pi over 2, or 0 and 90 degrees. Now, pi over 2 is 1.57. So if we are really good at recognizing angles, can you see that 2.45 is bigger than 90 degrees or bigger than pi over 2 radians? So that's another indication that this is wrong, but sometimes we don't see that because we're not used to looking at radians as much. So I have to go back to my calculator, and for the second one, I have to do cos inverse, use my fraction button, and I have to change this fraction to a positive. How do I do that? Well, I could multiply the top by a negative. I can multiply the bottom by the negative. I can put a negative in front of the whole fraction. -1 minus the square root of 13 over 6. So since it was a negative number, I took that fraction, I put a negative out in front, and now my reference angle, 0.70, is between quadrants, is between 0 and pi over 2. So now to find my actual angle, I have to find an angle in quadrant 2. I'll go to my calculator. I'm going to store this answer as x. And so in quadrant 2, it would be pi minus my reference angle. And in quadrant 3, it'll be pi plus my reference angle. So 2.45 and 3.84. Notice that I stored my value and used all my decimal places. I didn't want to round until the end. Again, just above these, I'm going to write that this answer was in quadrant 2, this answer was in quadrant 3. On this side, I'm going to go back to my calculator of that value, so I have to go up a fair bit till I get to that 1.12. I'm going to store that now as x. And I'm looking for quadrant 1 and quadrant 4. Pi minus my reference angle will be quadrant 4. Quadrant 1 will be 1.12, and quadrant 4, 5.16. So again, above these, I'm going to label this one was the answer in quadrant 1. That's the answer in quadrant 4. So I have solved, right? These are all the answers between 0 and 2 pi. But what do I need? What was my original question? Did they change the domain? Yes, they did. -pi to pi. So when I'm thinking about my positive answers, 0 to pi is quadrant 1 and quadrant 2. That means this answer is fine and this answer is fine, but these ones are not in my domain. In order to find out what they should have been, well, in quadrant 4, I'd have to go negative. It's going to be the same as my reference angle, so that'll be negative 1.12. In quadrant 3, this will be same reference angle. It'll be like quadrant 2 in the negative direction, so it'll be negative 2.45. Finally, does this one ask for the general solution? It does. So our general solution, we take all 4 of our answers. I'll write them in order. From 0 to 2 pi. Add 2k pi to each of them, where k is an integer. Okay, so your questions for practice are 12, 13, and 14. And question 14, you can factor